Hi, welcome back to edquest. I am your instructor, and this is our final and the most action-packed session in the model security part. Let's fast forward and take the similar example which we discussed in the previous sessions, the healthcare startup. The healthcare startup has deployed its machine learning models very securely, but now they face new challenges. For example, live attacks, user misuse, and the need to prove compliance. To overcome these type of challenges, we are dividing this session into three major parts. First one is the monitor and respond. Then framework and compliance, what type of frameworks we can use, and the adversarial attack defense system. First of all, I'm talking about the monitor and respond. As clearly mentioned, we can track the input and output anomalies, and based on those anomalies, we can take the further actions. We can implement some automated tools that can help us to detect the anomaly and overcome that. We can automate the model drift detection part, and that automation may help us and tell us very clearly like this model is drift and we have to retrain this model. Third, we can introduce the alerting mechanism that can help us to provide the accurate alerts based on the model performance, if that model is doing well or not. If that model is not doing well, then we can go for the rollback. Next is the framework compliance. We can use these type of tools which can help us to introduce the compliance into our model security or the machine learning security part. The company aligned with these key frameworks like NIST, AIRFM for risk management, the ISO 27001 for information security, OWASP ML Top 10 to address the most common machine learning specific threats. And the third major part is adversarial attack mitigation. Let's talk about how attackers can trick even the smarter models and how we fight back. Some of the most common attacks like FGSM, which stands for Fast Gradient Sign Method, and PGD, Projected Gradient Descent, work by making tiny, almost invisible changes to input data. To us, the image looks exactly the same, but to the model, it's suddenly confident that a cat is a car. So, how do we protect against that? Defensive distillation helps by training the model to be less sensitive to those subtle tricks, almost like teaching it to stay calm under pressure. Feature squeezing simplifies the input, stripping away unnecessary noise, so there's less room for manipulation. And model watermarking. Let's quietly embed a signature inside the model that will help us to provide a specific signature that can tell us it's ours. If someone else is trying to steal or copy it, it will prevent. These are just technical tools. They are part of how we defend trust in machine learning. Our deep dive into securing your machine learning models, you are now equipped to think like a machine learning operations security expert. Thank you.